Ladies and gentlemen, come one, come all, welcome to the 2022 Electromagnetic Universe World Expo. This next speaker, we have FractalWoman, aka Lori Gardi. Lori Gardi is a computer scientist and fractal cosmologist. She has written many papers, including one called Planck's Constant and the Nature of Light, of which this video is based. Another paper called The Mandelbrot Set and Quasi-Black Holes may also be of interest to the audience. By day, she works in the field of medical images, where she designs software for advanced medical devices that are used in point-of-care and surgical settings. She is also a computer artist and is currently working on a project to deploy her art in the NFT community.
Hello and good day. My name is FractalWoman, and I come from planet Buddhabrot. First of all, I'd like to thank Buddy James for inviting me to speak at this conference. Buddy is actually one of the very first people I met when I came to this planet, and we hit it off right away. So I'm grateful to be here, and I really hope I can offer some insights and help you all move forward into the future with an unambiguous and true understanding of light, the electric universe, and everything. On our planet, we do physics very differently. This is to be expected, of course, since we did not take the same path that you did on our journey of discovery. We did not have a Newton or an Einstein or a Maxwell or a Richard Feynman, and of course, we have a different language with different symbols. This makes it very difficult to communicate our cosmology to the people on other planets. It took many years to figure out how to bridge the gap between your language and our language. During this process, however, I discovered a few problems that might seem trivial at first, but they turn out to be non-trivial and very important. As we expect, the problem is not with the physics. The problem is with the language. So in order to move forward into the future, I think it's important that we take a few steps back to try to see where things went wrong. I think everyone in this conference feels that there is something terribly wrong, even if you can't quite put your finger on it. After spending all those years bridging the gap, I believe I have gotten to the root of the problem. The problem is not with the equations or the math. The biggest problem is with the interpretation of the equations. Just because you get the right answer that matches prediction does not mean that you are interpreting things correctly. Planck's energy equation is a good example of this, and that is what we're going to talk about today. After doing a thorough analysis of this equation and its history on your planet, I came to realize that you were missing a very small but very important piece of the puzzle. I stumbled upon two independent researchers that also came to this conclusion. Okay, one is Juliana Mortensen and the other is Lori Gardi. It appears that Mortensen discovered the source of the problem and Gardi took the ball and ran with it. I highly encourage you to look up their research, as I think you will find it very enlightening. So what are we missing? It has something to do with what you call unit analysis or dimensional analysis. On our planet, we refer to it as domain analysis. In your language, the word dimension has many meanings, making it ambiguous and a possible source of misinterpretation. That said, your dimensional analysis and our domain analysis are actually very similar. In your international standard, you have the following domains and associated base units. We have the domain of time with the unit of the second, the domain of space with the unit of the meter. You have the domain of mass with the unit of the kilogram, and the domain of charge with the unit of the coulomb. Now, of course, on our planet, our second is different than yours, our meter is different, and our domain of mass is different. We don't have a kilogram. We have a different mass as our standard, and the domain of charge is different. But regardless, we have a standard and you have a standard, and as long as you stick to the standard, then everything works out fine. We define another domain, which we refer to as the domain of frequency. Now, one of your historical figures once said, if you wish to understand the universe, think of energy, frequency, and vibration. Now, you really should have listened to this guy because he was really on to something. Now, the domain of frequency contains two base units, the radian and the cycle. The radian refers to the phase of a wave, or alternatively, it could refer to the angle of a circle. And cycle refers to one complete wave, one complete wavelength, or one complete period of the wave. Alternatively, it could refer to one complete turn around the circle. So what I discovered is that, yes, your international standard does have the unit of the radian, and you primarily see that when you're talking about angular frequency, but the unit for the cycle seems to be completely missing. And this, I believe, is the source of the problem and the source of the confusion when trying to understand the nature of light. So here's how we use the cycle unit in our language. The unit of frequency is cycles per second. The unit of the period is seconds per cycle. The unit of wavelength is meters per cycle. And the wave number, what you call the wave number, is cycles per meter. But in your language, the unit of frequency is 1 over s. The unit of period is just s. The unit of wavelength is just meter. And the unit of the wave number is 1 over meter. And so taking the cycle term out of the language gives an incomplete picture of these terms, and so we notice that this could possibly and did actually cause a misunderstanding, a misinterpretation of Planck's energy equation. The unit of the radian has a very limited use in our language. We prefer to stick to cycles, complete cycles, when we're doing our physics, but sometimes it's useful to talk about radians, and so angular frequency has units radians per second, and this one's actually very important. 2 pi in our language has units radians per cycle. 2 pi is the number of radians in one complete cycle, and so we define the units of 2 pi to be radians per cycle. Now, this is not possible in your language because you don't officially have a unit for the cycle. So this again is part of the source of the problem that I discovered when you don't have an official unit for the cycle. Then you end up with maybe defining the units of 2 pi as radians alone. But 2 pi is a very specific constant. It is a constant of nature, and it very specifically has units radians per cycle. So on our planet, we use domain analysis to make sure we are interpreting our equations correctly. Doing domain analysis prevents us from making mistakes. If you write an equation and the units don't balance, then you have a problem. This is exactly what happens in Planck's energy equation when you ignore the cycle term. Here is how the units of Planck's energy equation are written in your current language. The units of Planck's constant are joules times second, or what you refer to as the action constant, and the units of frequency are written as 1 over s. Now this, putting a numerical value into the unit section is actually bothersome. Numerical values do not belong in the unit section. It is specifically prohibited in domain analysis, at least the way we do it on our planet. Now I understand why it was done this way. It has something to do with cycles being countable. But I can also count seconds, 1 steamboat, 2 steamboat, 3 steamboat, etc. But we do not write the units of velocity as meters per 1. So putting this numerical value into the unit section and using it as the numerical value of 1 is a big problem. In domain analysis, the units of frequency are cycles per second. So now it is much easier to see that the unit section of this equation is not balanced. In order to balance the unit section of this equation, we need to add another cycle term. Now, the cycles cancel, the seconds cancel, and you end up with the unit of joule as expected. Of course, the equation itself was always balanced, but the unit section was not balanced. And since unit analysis, domain analysis, is primarily used for interpretation, any interpretations that you got when you wrote the units like this have to be called into question. So with the units written like this, how do we interpret Planck's energy equation? The units of frequency are cycles per second, so that is fairly straightforward, maybe a little bit more clear than your historical way of doing it. But how do we interpret Planck's constant itself? Planck's constant has these units right here. So as you can see, as we saw previously, seconds per cycle are the units of the period. So now the units of the period are in the units of Planck's constant. And the period is the time for one complete cycle of a wave. So Planck's constant interprets as the energy of means times, so the energy of one complete period of a wave. In other words, Planck's constant can be thought of as the energy of one complete cycle or one complete oscillation of an electromagnetic wave. Now, it can still also be thought of as an action constant, only the action is more clearly defined in that it is associated with the cycle, with a complete cycle, one complete cycle, or one complete oscillation of the electromagnetic wave. So if Planck's constant is the energy of one period of light, one cycle of light, and frequency is the number of cycles per second, then we have no choice but to interpret Planck's energy equation as the energy delivered in a 1 second time interval. So basically what I'm saying here is that each oscillation of light carries the same energy defined by Planck's constant, but different frequencies of light deliver different amounts of energy in a 1 second time interval. Preposterous, you say. Everyone knows that shorter wavelengths of light are more energetic than longer wavelengths of light. Do you know this? Or do you assume this? Here's what we know for sure. Higher frequency light is more energetic than lower frequency light. But does this mean that shorter wavelengths carry more energy than longer wavelengths of light? Of course, higher frequencies of light are more energetic than lower frequencies of light. That is because more energy units are hitting the detector in each unit of time of the experiment, which happens to be 1 second in your international standard. But this does not mean that one period of light, one cycle of light, one wavelength of light of a higher frequency carries more energy than one period, one cycle, one wavelength of a lower frequency, which has a much longer wavelength. Here's another way of looking at it. Forget about wavelength. Let's think in terms of wave fronts. Each wave front carries the same energy, but more wave fronts are hitting the detector when the frequency is higher. This way of saying it makes more sense logically. Wavelengths are just the distance between wave fronts. Okay? Wavelengths do not carry energy, wave fronts do. This is where I believe the misconception of Planck's energy equation comes from. You are thinking in terms of wavelengths instead of wave fronts. Okay, this all started with the experiment used to separate out light into different wavelengths. It is called a spectrograph. Okay, so what is a spectrograph? Here is a schematic of a spectrograph. Okay, a spectrograph splits light into its component wavelengths. First, light travels from a telescope through a small opening into the spectrograph to a columnating mirror that lines up all the entering rays of the light parallel to one another before they reach a finely scored plate of glass known as a diffraction grating. When the light passes through or bounces off the glass grating in its many constituent wavelengths, each change speed and direction according to their spectral color. The grating bends red light in a different way from orange light, which bends a little differently from yellow light, and so on, spreading the many wavelengths into a rainbow spectrum. Rotating the diffraction grating controls which wavelengths of light reach another mirror, which in turn focuses these wavelengths onto a photodetector, such as a charge-coupled device. The detector converts photons into electrical signals that a computer interprets to measure the strength of the different wavelengths. So the spectrograph reports their results in terms of wavelength, but then, in order to use Planck's energy equation, you need to convert from wavelength to frequency using the following formula. Now we have a frequency term to plug into Planck's energy equation to get a result in terms of energy. But this conversion from wavelength to frequency is also a conversion from the unit of the cycle to the unit of the second. In other words, it is a conversion from the domain of one cycle to the domain of many cycles. Planck's energy equation is the energy of many cycles, not one cycle. It is, in fact, the energy of 1 second worth of wave fronts. In 1 second, many wave fronts hit the detector. Each wave front carries the same energy defined by Planck's constant. E is not the energy of a fundamental particle called the photon, nor can it be. This is a mistake in interpretation of Planck's energy equation caused by the removal of the cycle term from the language. So now I'm going to do something a little different. I'm going to write the Planck's energy equation in terms of units alone, and then I'm going to divide both sides by S. When you divide both sides by S, you end up with these units here. Now I'm going to write the equation that corresponds to these units right here. This reads power equals Planck's constant times frequency. So now I've written Planck's energy equation in terms of power. So why would I want to do this? Well, the reason is, if you look back in your history books, you will find that the original black body experiments, which were performed, which actually were used to discover Planck's constant, were reported in terms of intensity. So they reported wavelength versus intensity, and intensity has the units of watts per meter squared. In other words, the black body experiments were reported in terms of power. So it's perplexing to me why historically this equation was written in terms of energy when the black body experiments were written in terms of power. It makes more sense to write this equation in terms of power. When you write it in terms of power, then for one, you don't have the confusing action constant. And also, so Planck's constant now interprets as joules per cycle, which is the same interpretation as the energy. So this is the energy per cycle, and before it was the energy of one period of light. So Planck's constant interprets the same as it did before, only the output of this equation has the units of power. And this is how we interpret this equation on our planet, and we get very good results when we do our experiments. We get the right answer that we expect, and it's just a different interpretation. There's nothing different in terms of the equation is the same, the values are the same, and the output is just interpreted differently. And this, when you interpret it as power, it leaves very little doubt that we're talking on a per second basis. The output of this equation is on a per second basis. So I'm going to leave it at that. I'm sure I've given you lots to think about. What you do with this information is entirely up to you. I am merely the messenger. So thank you again, buddy, for inviting me to give this presentation. I hope everyone is having a great time at the conference. I wish I could be there in person. It sounds like it's a heck of a lot of fun. I would love to be there, but I hope you all are enjoying it, and well, have a good day.
Thank you very much for joining us for this presenter, Lori Gardi, and the 2022 EM World Expo. We will see you next week with another presenter. Till then, have a wonderful week.